Hello, calculus. Welcome back. Our objective for today is to find and interpret the derivative at a point. I have the checklist, so make sure you've got everything ready to go. Make sure you're in full screen mode. I'll force a pause on your screen. All right, I'm going to force another pause on your screen. I'd like for you to copy what's on my screen, including the graph, please. All right, so calculus has two branches, differential calculus and integral calculus. And differential calculus is actually all about slope and its applications. So what we're going to do is find the slope of the secant line, which is this green line that we found here, and then use a limit to find the slope of the tangent line. Okay, so here's what I'd like for you to do. I'd like for you to put some labels on this graph for me. I'm going to call that x. Okay, and then I'm going to move over h units on the x-axis, and this will be x plus h. Okay, and then let's also find these y values. So if this blue graph, let's just call it generically y equals f of x, then do you agree that whatever this x value is here, if I would just plug it into f, I would get the y value there, right? Like if this were x equals 2, then the y value here would be f of 2, correct? Okay, so if this is x, the y value here is going to be f of whatever that x value is. And then again, if this, let's see here, if this x value is x plus h, then the corresponding y value up here is going to be f of x plus h, right? All right, so the slope of a line is my change in y. We do a little triangle, it's a Greek letter delta, which we usually use for change. Change in y over change in x, right? So my change in y will be right there, so it'll be this y value minus this y value. So that will be f of x plus h minus f of x, that's my rise, right, over, now my run is right there, that's my change in x, okay? So I've got x plus h minus x, in other words, just h, correct? So that's the slope of the secant line. So then, in order to find the slope of the tangent line, I want to take this x value and force it closer and closer and closer to that x value. In other words, I want to take a limit, okay? So I want to take the limit, in this case, as this change in x, which remember we said was h. I want to take the limit as h approaches 0 of this slope. So I'm going to rewrite that, f of x plus h minus f of x all over h, okay? And when we find this limit, this is a very special limit in calculus, this is called the derivative, and we denote it as f prime, which looks like a little apostrophe, so f prime of x equals that limit, okay? So very, very important formula for calculus. So I want to show you kind of again graphically what's going on here. So if I've got a generic function like this red parabola, for example, you can tell this green line is the secant line, and secant in Latin means to cut. So I'm cutting the graph at 2 points, and what we can do is as I move that, so as we drag this orange dot closer and closer and closer to the blue one, so we get infinitesimally close, we're taking that limit. So that limit of that fraction that we wrote earlier, that's what we're finding right about there. That's the tangent line, okay? So tangent line occurs in on one point on a graph, and tangent means to touch in Latin, whereas secant, again, to cut, is 2. And the only difference is that with the tangent, you're taking the limit as that orange dot is getting closer and closer to that blue dot. So right at 1 point. All right, so let's try an example. This is example 1, method 1. Can you write this function in your notes, please? As well as x equals 1. And we're going to find the derivative at x equals 1 by the limit process and then describe what we found. So We've talked about a function being differentiable, and differentiable simply means that the slope exists, okay? That's the adjective. But if we want to find the derivative, the noun, that is, okay, what is the slope at that point? So if I zoom in enough, once it starts to look linear, can I calculate the slope at one single point? So the derivative gives me the slope of the tangent line, all right? So let's try using the limit process here. All right, so let's first write our derivative formula at x equals 1, okay? So remember, f prime means the derivative, which is, again, finding the slope of the tangent line. So I'm going to go f prime of 1 in this case. And the formula goes limit as h approaches 0 of f of x plus 1, but again, I'm sorry, x plus h, but again, x is 1. So 1 plus h minus f of x, which again, x is 1, all over h. Okay? And as we get kind of comfortable with these, I sort of like to do this in 3 pieces. So I'm going to find f of 1 plus h first, and then I'm going to subtract f of 1 and then all over h. Okay? So let's go piece by piece here. We've got the limit as h approaches 0. Okay, so let's find f of 1 plus h first. So if I asked you to find f of 2, that means you would plug in 2 anywhere you see an x, and I see 2 x's there. So if I asked you to find f of 1 plus h, that means you're going to plug in 1 plus h anywhere you see an x. So I'm going to replace this x with 1 plus h and that x with 1 plus h, okay? So we've got, I see an x, I'm going to replace that with 1 plus h, then I see a squared, plus, then we've got a 2, then I see another x, so I'm replacing that with 1 plus h. Okay, so that red piece is that. Okay, now I need to subtract f of 1. Okay, how do I find f of 1? Well, this time everywhere I see an x, I replace it with 1. Okay, so for f of 1, I've got 1 squared plus 2 times 1. All right, okay, and then we're going to go all over h, okay? And by the way, if we try to plug in 0 for h right now, we'll get 0 over 0, so we're working on our do more, okay? Okie doke, so let's keep going. Our do more is going to be, at this point, we're just going to do some algebra, and we're going to get some nice cancellation, okay? So I've got the limit as h approaches 0. All right, so for this, let's be sure we expand that all the way. So 1 plus h times another 1 plus h is going to be 1 plus 2h plus h squared. And then I'm going to distribute this too. So plus 2 plus 2h. And then I've got that yellow portion there. 1 squared plus 2 is 3, right? So minus 3 all over h. Okay, let's combine like terms. So I've got limit as h approaches 0. Okay, I've got 1 plus 2 minus 3. So those are going to cancel, right? 1 plus 2 is 3, minus 3 is 0. Okay, so now let's focus on what we have left. I've got 2h plus 2h, so that's 4h. And then I've got an h squared. Okay. All right, now we're getting pretty close. What can we do from here? Now we can factor out an h in both the numerator and denominator, right? So I've got 4 plus h left. Now I can divide out the h's. And now, finally, I can plug in 0 for h. So plugging in 0 for h, I get 4 plus 0, also known as 4. Okay, so that's the derivative of f of x at x equals 1. What did we just find? Well, we found the slope of the tangent line of f of x, that parabola, at x equals 1. All right, so what exactly is the slope of the tangent line? So I have our parabola graphed here. This is our y equals x squared plus 2x, and I've got the x equals 1 indicated, okay? So would you say that this function is differentiable? And sure is, it's continuous and smooth, right? So if I take that blue dot, and let's start zooming in on that blue dot till we get what looks linear. Okay, so if I now count the grids, let's see if we can find the slope of what now looks to be that red line. Okay, I know that it's actually parabola zoomed way in, but let's count. So I go up 1, 2, 3, 4, and to the right 1. So this part right here, if I zoom in enough, has a slope of what? It has a slope of 4 over 1, or 4, which is exactly what we found with the calculus. All right, I'm going to force another pause on your screen. Can you copy that graph again, and I'm going to show you a different method. All right, so for method 2, we're going to have the same theory. We're just going to call these points something different, which can make the algebra work out a little bit easier for us at times. So for method 2, we're going to label this x value a, and we're going to label this x value x. So this y value is now f of a, and this y value is f of x, okay? So if I take my rise, or my change in y, I have that difference, right? So my change in y is my top y value minus my bottom y value. For example, if this were 5 and this were 3, the difference, the change would be 2, 5 minus 3, right? So we're just using symbols instead of numbers so that we can generalize. Okay, and then my run is my change in x, right? So my right x value minus my left x value, okay? So that's the slope of the tangent line, again, secant line. If I want to find the tangent line, I need to force this x value closer and closer to that one, okay? So I need a limit. So for f prime of a, we are going to have the limit as x approaches a of f of x minus f of a all over x minus a, okay? And that is the second method for finding a derivative at a point. So please make sure you've got both written down. All right, so we're going to have the same question just using method 2 here. So we're going to find f prime of 1 still. Using our method 2 formula, we take the limit as x approaches a. But what is a in this case? A is 1. So as x approaches 1, of f of x minus f of a, but again a is 1, all over x minus a, which again is 1. Okay? All right, so now let's fill this in for our f of x. So I keep my limit as x approaches 1. What is f of x? Well, that's that x squared plus 2x. Then I want to subtract out f of 1. So what do we get for f of 1? Well, we get 1 squared plus 2 times 1. So 1 plus 2, so 3. And then all over x minus 1. Again, notice if you plug in 1 for x, you do get 0 over 0. So this is a do more. So what can we do more? What do more can we do here? We can factor, right? So I'm guessing one of my factors is x minus 1 in the numerator. The other one needs to be x plus 3, right? Now my factors of x minus 1 divide out. So now, plug in, I'm sorry, I lost my 1 here. So now we need to plug in 1 for x. So that gives me 1 plus 3, which is 4, which is what we got over here, right? So my preferred method is typically method 2. The downfall with method 2 is that it only works if you're looking at a particular x value. It's not going to find you the derivative in general, whereas method 1 can find the derivative for you at any x value, okay? All right. So it says describe what we found. Well, again, we found the slope of the tangent line. In other words, if I zoom in enough, remember our slope was up 4 to the right 1, so we had a slope of positive 4. All right, so here's example 2. Would you please write f of x equals x squared in your notes? And then we want to write but not evaluate our 2 ways to find f prime of 3. So I'm actually not going to have you do many of these by hand because we're going to learn shortcuts really soon. But what does pop up on the AP exam is, can you match the different methods? Then once we know our shortcuts, we can just use our shortcuts. So I do need you to be able to write out the limit definition of the derivative, but not necessarily go through all of that algebra, okay? Because we're going to learn the calculus shortcuts soon. But I do need you to be able to set it up for me, okay? So let's do method 1 first. Remember, method 1 looks like this. Method 1, we've got the limit, I'm just going to write the general method, as h approaches 0 of f of x plus h minus f of x all over h. Okay, so what is your f of x in this case? Our f of x in this case is x squared. And what is your x value? Our x is 3. So let's plug those things in to our formula. So we've got the limit as h approaches 0. So now I want to use, remember, maybe this is helpful, 3 for anywhere I see an x, right? So I am going to plug in 3 plus h anywhere I see an x. I only see one x. So f of 3 plus h becomes 3 plus h quantity squared, okay? Then I want to subtract f of 3. So f of 3 is 3 squared, or 9, either way. And then that should be all over h. And I just want you to leave it like that, okay? Setup only. All right, method 2 goes like this. The limit as x approaches a of f of x minus f of a all over x minus a. Again, f of x is x squared, and now a is 3. Okay, so we're going to have the limit as x approaches 3 of f of x, which remember was x squared, minus f of 3, and if I plug 3 in here, I get 3 squared, which is 9, all over x minus a, which again is 3. Okay, and you're just going to leave it there. All right, so here's some matching time for you. I want you to match something in the first column, something in the middle column, to something in the last column, okay? I'm going to force pause on your screen, but you'll probably have to pause yourself as well so that the box doesn't cover it all. All right, so we will talk about those answers in class. Let's review how to write the equation of a line in point slope form. A very classic differential calculus question is write the equation of the tangent line. Okay, so you now know how to find the slope. So now if I want to put it all together, the form we use the most in calculus is point slope. So as a reminder, that's y minus y1 equals m times x minus x1. Okay, x1 is typically what is given. If y1 is not given, you can just plug the given x value into f of x, right? And then how do I find the slope of the tangent line? Well, that's where we need calculus. So that's the derivative, in other words, f prime of x minus 1. So why do we care so much about tangent lines in calculus? Well, it's because the lines are so much easier to work with than any other function. And if you will notice, see that I've got the blue line is the tangent line here of the orange parabola. If I zoom in enough on that point of tangency, what do you notice about the orange and the blue? The orange and the blue start to look exactly the same. So if I stay close to the point of tangency, the slope of the tangent line is actually a great approximation for the function. All right, so here's our final example. It says approximate f of 2.1 if f of 2 is 3 and f prime of 2 is negative 1. Okay, so we first need to write our tangent line. So y minus y1 equals m times x minus x1. What's your x1? Which x keeps repeating? Well, we're looking at 2, right? So my x1 value is 2. And what is y when x is 2? 3. So I'm going to have y minus 3. And what's your slope or your derivative? Negative 1. Okay, so that's my tangent line. If I stay close to 2, I can use that to approximate my function. Well, we wanted to approximate 2.1. Is 2.1 close to 2? Absolutely. So go ahead and plug in 2.1 for me and solve for y, and then bring me your answer to class.